So you're saying the only possible flat map could be the AE map? That's what you're
Yeah,
saying?
based on the, there's other criteria you could use, but if you use the criteria that you want to get lines of latitude right, if that's the
All right.
criteria,
What if?
then the Gleason
Okay.
map has to be.
All right. So latitude and longitude kind of assumes a sphere. I mean, it totally assumes a sphere.
Sorry,
Got
not really.
Longitude lines intersect, and the latitude lines are not. They're parallel, but the spaces between them get shorter and shorter as they go towards the poles, right?
No, the lines of latitude are, whether you're talking about the Gleason map or the globe, the distance between lines of latitude are the same.
As you go up, the distance?
Yeah, the distance, the Gleason map gets the distance right.
70 north or 70 south, it's the same as the latitude lines at like fucking 10 south?
Yeah, the distance between them is the same. Their circumferences aren't right, but the distances between them are.
The circumferences aren't right.
Yeah.
But as you go up in latitude or down, the big circle is smaller or bigger. Am I right?
Not sure what you mean by the big circle. On the Gleason map, lines of latitude get bigger and bigger and bigger.
Latitude, hold on, latitude lines.
They're circles, right?
The equator, the latitude line at the equator is bigger than the latitude line, I'm saying the whole circle, when you're at 70 north or 70 south.
Right, and that's true on the globe or the Gleason map.
Now,
yeah, that's right.
longitude lines intersect at the poles, right?
Right. And they're straight.
Both these together are assuming a sphere. So the coordinate system.
What? I don't know what you mean.
Right out the gate. Right out the gate, it assumes a sphere.
No, I didn't. I don't understand. You can label points.
What don't you understand? Let's go to that.
Well, the point is that I can take the Gleason map. You tell me a latitude and a longitude, and I can locate the point on the Gleason map. That doesn't. The latitude, giving me the latitude and longitude of a point doesn't tell me what it is.
The coordinate system itself assumes a sphere.
No, it doesn't assume the sphere, but it is, you're right, based on the sphere.
Sphere, because if the latitude and longitude was squares, like a square grid, then it wouldn't be assuming a sphere. Like on a road map.
Well, okay, so I think we have to be really careful about what we know. What we know as a directly observed fact is that the lines of latitude are circles around the North Pole. They just are. You can measure the distance from any point on 80 degrees north, and it'll be the same.
Completely what I'm saying. I'm saying this coordinate system assumes a sphere. How does
well, I wouldn't put it that way, but okay.
Lines that intersect. They're not parallel lines, totally parallel lines.
Well, I don't know. I mean, I don't see. There's nothing about what you've said that isn't true on the Gleason map.
But so what don't you understand?
Well, I'm not sure. I don't understand anything. I don't understand the point you're making. Everything you've said is true, whether the Earth is a globe or the Gleason. Well,
latitude and longitude assumes a sphere. You could look at the
map. So what do you mean? What do you mean by that?
It's a globe projection, bro.
Yeah, that's right.
Flat map. How could it be a flat map if it's a globe projection?
Well, I couldn't agree more, but I'm just pointing out. I mean, my initial point was,
But what you don't agree on is that latitude and longitude assumes a sphere right out the gate. You could put.
Well, see that I just don't understand what you mean. When you say that it assumes the sphere, what result does that lead to for you?
Or not? Are they big circles? Latitude.
They're circles, yeah.
Okay, but they're not all the same. If you take the distance of that circle, the equator would be what? 25,8 something, 25,000, 8 or 900 or 800. Right?
I think it's about 25,000, 24,900 or something like that, right?
Okay, but as you go up or down, now the circle is smaller. It's not 24,900.
That's true in fact, right? It's not true on the Gleason map, right?
It'll change.
That's
So
right.
this is assuming a sphere, dude.
No, that's just a fact. I mean, we have to be clear about what we're assuming and what's not. It is a fact that southern latitudes have shorter circumferences than the equator. That's just a fact.
Right. Well, that's the system they created, which assumes a sphere. I don't understand.
Well, I
Why you
don't know
don't
what
see
that
this.
means. I mean, all I'm saying is that when you
I'm
measure
telling you
the
what it means. I'm talking
circumference,
about the coordinate system, man. Longitude lines meet at the poles. Latitude
yeah.
gets smaller or bigger per degree, right?
Well, I mean, there's a lot of things, that are simple facts, and you're right. It is a fact that latitude lines that aren't the equator, all latitude lines are
This is what I'm
shorter
saying.
than the equator, except for the
This
equator.
is what
That's
I'm
just a
saying. As
fact.
long as we
That
use
doesn't
latitude and
assume the
longitude.
globe.
Sorry.
That doesn't assume the globe. That's just a fact.
No, the coordinate system does assume a sphere. It's a spherical coordinate system, dude. It's a spherical graticule. That's it. That's all I'm saying. And what I'm saying is there can never be a flat map using this system.
Somebody's got a hot mic.
Yeah.
Look.
But what
Yeah,
I'm
it
saying
kinda
is there can
grossed me
never
out,
be a
too.
flat map using this system.
So I once again, I mean, it's okay if you want to say it is true that the latitude longitude system is based on a globe, but once you've got that system, nobody disagrees what the latitude and longitude of any point on Earth. It doesn't matter where it came from. We all agree
Totally
that the
matters.
latitude longitude of where I am is what it is, right? That's just a coordinate system
It
that
doesn't matter how you
locates
shape
me.
the latitude and longitude. The origin of it is spherical. You understand?
Well, I don't disagree, but all I'm saying is that once you've got that coordinate system, wherever it came from, it's now simply a fact that the circumference of southern latitudes are roughly the same as their northern hemisphere counterparts. That's just a fact. There's no assumption there. That's a fact.
What? Say it again. Sorry, I didn't catch it.
The circumference, say, of 40 degrees south is basically the same as 40 degrees north. That's just a fact. That's not. There's no assumption. There's no assumption there.
The latitude, the whole circle of latitude on that degree is going to be bigger or fucking smaller per degree. But yeah, at 40 fucking south, 40 north, they're going to be the same, right? Pick a number. 34 south,
Right.
34 north, they're going to be the same, right?
Yep.
Okay, I'm not even saying that. What I'm saying is latitude and longitude is spherical to begin with, so you cannot have a flat map.
Well, see, I don't agree with that. I mean,
latitude and longitude, it's a sphere right there.
well, see, fair enough. I disagree with that. I would agree, I think, with most flat earthers that just because we have a latitude longitude system doesn't mean the Earth is a globe.
I'm not saying that. I'm saying that the coordinate system itself assumes a globe.
I think he's talking about the graticule, that it's curved before you enter information, because
Yeah,
that's how it's
that's what I'm saying.
processed.
Right, but I mean,
It doesn't mean it's wrong. It means that no matter what you're computating, it's already that result.
oh, but we don't compute distances from that. We measure distances, and we can measure the distance of each degree along the equator. We can measure the distance of each degree along 40
That's
degrees,
fine.
etc.
But could you acknowledge that it is the case? I have yet to hear someone be honest enough to just be like, okay, well, the graticule is a curved system, instead of just moving the goalposts like, well, we do these other things too. But
the
yeah, but can you?
the graticule does come from the fact that the Earth is a globe. That's why we have the graticule, and it wouldn't make sense to use it on a flat Earth. Well, it would actually. I take that back. I mean, it really does. It totally makes sense to use latitude, longitude on the Gleason map. How else would you do it? Are you going to have rectilinear coordinates on a circular Earth? It doesn't make sense. On the Gleason map, it just becomes what we call a polar coordinate system, not a spherical. It's a polar coordinate system. It's radius and azimuth on the Gleason map, and there's nothing wrong with that. Right? You can have latitude, longitude. It doesn't mean a sphere. It could mean a circle. Gleason map uses it in a perfectly reasonable way.
Map, but originally latitude and longitude assumes a sphere. From there, you could take it, you could turn it into whatever type of map. But the origin of it is spherical, bro. That's all I'm saying. So we can never have a legit model, dude.
Look, the shape of the Earth isn't determined from a coordinate system. It's determined by getting distances. If I measure the distance from Los Angeles to Tokyo and the distance,
You're starting with latitude and longitude, which assumes a
no, that's not what. That's not what. I just want to. If I just get in a jet airplane and I fly as fast as that thing can fly from Los Angeles to Tokyo, let me just finish my argument. If I fly from LA to Tokyo, okay, never mind.
Jet airplanes. Come on. I mean, seriously, come on. We're not talking about jet
I was reading something else. Sorry, I got a little lost. Is he trying to talk about something else, or is this related to the? What are you saying?
I don't know who he is.
Well, yeah, John, are you talking about something that's related to what Calm Down's saying?
Well, I'm not sure. I'm trying to.
I'm talking about latitude and longitude assumes a sphere, the graticule alone. That's all I'm saying. And you're saying it's not.
Well, yeah, no. So here's what I say. Latitude and longitude latitude in particular comes from noting that there are places on Earth where it comes from Polaris. It comes from noting, first of all, that Polaris doesn't. Basically, there is a north celestial pole, right? It comes from noting the fact that the celestial sphere rotates around a north celestial pole and a south celestial pole. Yeah, and then latitude comes from simply asking what part of that celestial sphere is directly above you, right? What is the effectively what's called the declination of stars that pass directly over your head? That declination is your latitude.
Right. Okay. Well, it still assumes a sphere, dude. However, they came up with it, and you can see that.
Well, so once again, I mean, I would say I think I think.
Matt, I mean, come on.
Okay, but, all right.
You either don't understand me or you're purposely just avoiding what I'm saying. I don't know what it is.
Well, what's the import? What's the import of what you're saying? I don't understand where you're going with it. Maybe you could go with it. Import. What is it? What conclusions do you draw from what you're saying?
We can never have a legit flat Earth model if we're starting with a spherical graticule.
Well, that's not true. That's certainly not true.
How is it not true?
Because I don't care what coordinate system you can use. You can calculate. You can measure the distance between things. And if you measure, for instance, let me just do this one thing. If I determine, just for instance, if I determine the distance of the equator from the North Pole to be 10,000 kilometers. Right, which it is, and you can measure that. You can travel toward. No, can I just finish? Can I just finish?
Yeah, you're just going off topic of what I'm saying.
Okay, never mind.
Yeah, you're just avoiding what I'm saying. That's all.
He's talking about, okay, so Calm Down is talking about the canvas of your modeling system. The canvas is already curved. So regardless of how you're interpreting any amounts of measurements or data, it's going to be conformed to this canvas shape.
Well, if the canvas is curved, then I rest my case, right? I can put coordinates. I can put latitude and longitude coordinates on a flat plane. Now, that's what the Gleason map does.
The Gleason map is a globe projection, and latitude and longitude assume a sphere. That's what I'm saying, and you're saying it doesn't.
Well, okay, so if it were the case, let's say that the Earth isn't a sphere, it would still look like a sphere whenever you interpret that data because of the canvas shape. So then we come into a conflict because if light doesn't travel straight, for some reason it doesn't travel straight. I know that the globe claims that there's parallel light, but then we try to triangulate the sun from different locations. It's like a rainbow here. It doesn't triangulate to the same spot.
What does? I mean, the direction to the sun from every place on the Earth is the same. That's because it's a distant object. Distant object. When I point my camera at the sun and you point your camera at the sun, if you're in New York and I'm in LA, we're pointing our cameras in exactly the same direction.
That's not what I've heard.
If the sun were local, we wouldn't be, and then we could use the angles between those to tell us how far away the sun is. But the reason the flat Earth doesn't have a number for how far away the sun is because when you do that basically that Eratosthenes experiment, the answer you get depends on the locations of the cameras. And it shouldn't, right?
Points.
Right, if you take any 2 points on the Earth and triangulate to the sun, you'll get different answers for how high it is if you assume the Earth is flat. But if you assume that the Earth is a globe, you'll find out that every single camera on Earth, when it points at the sun, is pointing in exactly the same direction. It's a different local azimuth and elevation, but it turns out to be exactly the same direction. That's why when I took pictures of the sun, when TFE was in Antarctica, they were taking pictures of the sun. I took pictures of the sun, and I flipped them by almost 180 degrees to get the pictures that I knew they would be taking. I knew they were pointing their camera in the same direction, but their camera was basically upside down from mine. When I flipped my pictures by 180 degrees, the sunspots were the same as the sunspots they saw.
Yeah, I wouldn't expect the sun to be entirely different. So I would imagine the sunspots are there. If everything is opposite, sunspots would be opposite. So.
Well, I mean, you say you would expect. I assume you mean on a globe Earth. I mean, that is to be expected. I knew that they were standing on their heads, right, relative to me, and so they would take a picture that was upside down from the picture I took, and indeed, that's what they saw. Their sunspots were upside down from mine. But we were pointing our camera in the same direction, the exact same direction, because the sun is so far away.
Well, I come from a position that visible light, especially, doesn't really travel straight, and it would be very hard to make it do so. So
why do you think that? What's your evidence? What's your theory?
I think that we often spend a lot of time trying to maintain a position of the best. I would say like people go way out of their way to try to get the best conditions for any particular observation or control for what they're trying to do. And it always appears to me that the best results tend to be the clearest and the least distorted. So when there is less information loss, less distortion, you get the best results. But it appears that there's a bunch of stuff in the air. It appears that there's a bunch of different temperature because of this radiation or that wind or whatever. There's a bunch of reasons. But the globe, it tries to double down on something that's mostly inconsistent. And then say that's the reason why it's around Earth. But when it's the clearest, that's when we see the furthest. So it doesn't make sense.
Well, so you're talking, when you say 9 straight lines, you're talking about refraction, is that thing?
Yeah. I mean, we have a presentation last night from using Leyland, and he went into detail showing that light is very curvy. So it's actually actually literally have to split right now and release a video of it. So I'm going to have to go for the
Well, so I'm just saying, my position is light is not very curvy. When you talk about the maximum amount that light ever curves in the atmosphere, it's like half a degree. And that you can't even see that. If you let a ray that's curved half a degree, you swear it's a straight line. Light does not curve very much.
Just not my experience. Like light curves and diffraction and help on this.
Diffraction is another thing. Diffraction is diffraction in the atmosphere, not diffraction, which is massive obstacles and stuff like that.
Over miles, it actually drastic. So I mean, I'll just have to cut this clip and just let you watch it and you'll critique his points because otherwise it's kind of like.
What do you agree with?
Hold on.
Yeah, okay, go ahead. Go ahead.
See what I put in the chat right there?
Not the thing Jesse just put. Let's see. Where did you put it?
Before that, the whole thing.
Oh, I'm sorry. Yeah, oh, yeah, that thing. Right. Oh, no, that's left lane. No, I'm not seeing. Actually, I don't see. Did you put it in which chat?
Yeah, it's right below the GIF of it.
Oh, is it? Okay, thanks, left. Oh, you mean just the words? Okay, let me read it. Yeah, okay. I mean, I don't disagree with any of that, so that's true.
What I'm trying to say. From the beginning, we cannot have a legit model.
See, that's wrong, though. That's just wrong.
What's wrong?
What you take from that, because the Gleason map is a flat map. It uses latitude and longitude coordinates, and you're right, it is a projection. But if the Earth were flat, you could use exactly those coordinates, and they'd be just fine. But in the end, the only thing that matters is that you're able to get distances between any 2 points on the planet correctly, and that's what you can't do on any flat Earth
Do
map.
you understand what projections are?
Yes, totally.
Cartography. Okay, then. Why are you saying that it's a flat map then? If it's a globe.
It is a flat map.
No, it's not. I mean, a map is flat. It's not a globe. An actual
Yeah.
map.
No, I'm saying that if the Earth
Projection turned into a map.
if the Earth were flat and circular and had the distance relationships that the
Why does
I don't know, it doesn't have to be. I don't care. I'm just saying that the Gleason map is a perfectly reasonable model, right? Put that model out there. You check some entailments of it. You find out that it's wrong, but it could be.
No, it's not. And people need to realize it's not.
So let me see if I can just get through this because it's kind of important. The equator is a circle that is 10,000 kilometers in radius, centered on the North Pole. That's just a fact. That's a fact. It has nothing to do with the shape of the Earth.
You know someone that went around the whole equator?
You don't have to go around the whole equator. You can take any piece of it. You can drive along a highway. You can ascertain. No, let me just finish. You can ascertain that the distance that you travel when you go from a place that has a longitude number of 5 to a longitude number of 6 is 69 miles, or 111 kilometers. You can verify that. You can do that anywhere along the equater. Verify that's true. At every point on the equator, you can road. You can ride a boat along. Oh, you can fly out. So that's what you can things along it. Any way you want. You can measure distance around the equator.
When did someone just go all the way around the equator?
Well, I don't know. That doesn't have to happen. You can measure each side. You don't think you can measure each side.
Yeah, anyway, I'm talking about
What's I know? You finish my argument for the third time. Okay, if you think so, I would like to give it so that you can decide whether it's pointless. It's very simple. It's very simple. The thing is that if the Earth is flat, then I don't care about coordinate systems. Here's something that will be true. The circumference of every circle. Good Lord, can I just finish? I'm like, I'm
like, you're a fucking science major, dude.
He is a science major.
He is a science major. That's why I invited him here, Jim. Yeah, he's a dude. John, can you just share your credential with us? He's not in the field anymore, but he's go ahead.
Yeah, no, I mean I can, but it doesn't matter what my credentials are if what I say doesn't make sense.
I think it's pertinent to his ability to question you and know what to ask of you and stuff. So
I taught physics for 30 years. So I'm a PhD physicist and I taught physics for 30 years. But it doesn't matter what my credentials are. The only thing that matters is if things I say make sense or not. And if they don't make sense to you, I can't do anything about that.
The things you say make sense, but I feel like you're just going off in another direction from what I'm talking about. That's all.
Well, I feel like I'm not allowed to make the single argument. I'll just try to make it quickly. If the Earth is flat, all circles will have circumferences that are equal to pi times their diameters. And that's just not true on the Earth.
Okay, well, I don't think that's what I was talking about, but okay. I'm just talking about latitude and longitude. We were talking about the A map, and you're saying that's a perfect flat Earth model, but it's not because we know that it's a globe projection, man. And to begin with, latitude and longitude is a spherical system. I mean, you taught physics. I don't understand why you don't see what I'm saying. It's true.
No, I see what you're saying. I'm just saying that the fact that the coordinate system is based on the fact that the Earth is a globe doesn't in itself rule out the Earth being flat. You can have that coordinate system, and you can still prove that the Earth is flat. By simply showing that every circle has a circumference equal to pi times its diameter. That's all you need to do.
Look, okay, it's not a good model, dude. If it's inherently fucking spherical, bro. Like, how could that be a legit model for flat Earth? It can't be. I mean, I don't understand.
Once again, if the Earth is flat, every circle will have a circumference pi times its diameter. And on the Earth, that's just not true.
What does that have? Like, what is
That's why the coordinate system doesn't matter. All you have to do is take the circumference of a circle and compare it to its diameter.
When you look at a road map, like the Thomas Guide, it's set up A, B, C, D, 1, 2, 3, 4, and it's squares, bro. That's a it's a flat map. Spherical fucking map.
Right, it's a flat map because the Earth is really flat on the scale of the Thomas Guide.
Right.
There's no physical surface that any human being has ever encountered that is as flat as the so-called reference ellipsoid. The reference ellipsoid that all surveyors use is an ellipsoid, and it is flatter than any physical surface that any human being has ever encountered. That's how flat the Earth is. It's really flat.
Let's talk about this land surveying. When they first surveyed the United States, the 48 states, do you know what kind of maps they made?
I don't. I'm sorry, Shubil isn't here. He could definitely answer this question.
Well, anyway, like in 1947, they started these quadrangle maps, 7.5-minute quadrangle maps, right?
Okay. Oh, yeah, I'm familiar with that from hiking. Yep.
Well, they took plane surveys, and then they added in the spherical stuff, the WGS 84 or whatever it was at the time. That's what they do, man.
Right.
That's what they actually do, and then they string them all together, and they do the same thing you
Yep.
said. They said because it's only 57 square miles, the curvature is negligible. So then they string all
Yep.
these together. They made 55,000 maps of the 48 states, and they put them together. But what makes it spherical is the latitude and longitude. When they put it into latitude and longitude, it's only a little bit of curve, but when you put it all together, that's the fucking reference ellipsoid or the geode or whatever they use.
Yeah, that's right.
Yeah, so what I'm saying is originally they take planar surveys.
Right, and if the Earth weren't curved, they wouldn't have to do the fiddling around that they do. They could just put them together and have a big map of the Earth. But you can't, because on large scales, the curvature starts being large enough that it matters.
Yeah, I mean that's where we're at. Like you say that there is curvature and we say there isn't. And like when they first map it at the small scale, they're not detecting curvature. They're adding it with whether it be the WGS 84 or the EGM 96 or the geod, whatever it is. They add that shit. And it's also added through latitude and longitude. So
So the 7.5 minute maps up at I've never really looked at this, but if you look at them in Montana, say, versus Florida, there's a different scale, right? For if the map is the same size, I think they're all usually printed to the same size. But the 7.5 minutes up in Montana of longitude, 7.5 minutes of longitude, just isn't as long a distance as it is in Florida. So they have to accommodate that, right? You couldn't just take those maps and glue them together because they have different scales.
that's exactly what my point was with latitude circles being different sizes and they assume a sphere. He's making my point. Yeah, the point is, bro, they take plane surveys to begin with, and
Right.
then they add all this other stuff.
Well, they add the other stuff because they have to, right? I mean, if they didn't have to, they wouldn't.
They have to. Exactly, they have to.
So, John, would it be more accurate rather than saying the spherical coordinate system does not assume the globe? It is a consequence of the shape of the Earth.
Yeah, I mean, I was trying to avoid saying that. I think that's true. We come up with the latitude longitude system. It's an obvious thing to do because of the fact that the celestial sphere arranges itself that way, right?
Circular reasoning, right? Do I have that right? It sounds like circular reasoning.
If you simply take all points for which Deneb, crosses directly across the zenith every day, that's a line of latitude. Take any star, collect all the points that star passes directly overhead. That's a line of latitude, and it's a circle centered on the North Pole. And we can measure the distance to the North Pole from that circle. We can measure the circumference of that circle, and the circumference of that circle divided by the distance to the North Pole is less than 2 times pi, which tells you right away that the Earth is not flat.
Yeah. Anyway, dude, good talking to you. We're not gonna agree on this, but yeah.
Okay. Yeah, no, I appreciate it.